Okay, so we're going to do some examples of the problems on the ones that you were having trouble on. I think it was Journey 10 Lab. These are some of those stoichiometry problems that show quantitative relationships between the reactants and products in a chemical reaction. So here we have our first chemical reaction. The way to read this would be 2 moles of hydrogen gas, right? 2 moles. So the coefficient is the 2, and it gives you the number of moles. And then remember that the 2's or the subscripts beside the symbols give you the atoms, the number of atoms of that element. And that's going to determine what compound it is. And so we have, we would write that as 2, or we would say that as 2 moles of hydrogen gas. Just to go over so you know how to interpret this. And then 1 mole, whoops, 1 mole of oxygen gas, right? Because if there's nothing here in front of the oxygen, if there's no coefficient, then we assume 1. And then that would yield 2 moles of H2O, which is water. And then all of these symbols, remember, these are the state symbols. It just tells you that all of these are in the gaseous state. And so here's our first problem. It's asking you to find, it says how many moles of N2, and of course N2 should be written with a subscript. It just didn't come out like that. So how many moles of N2, which would be nitrogen gas, are required to completely react with 4 grams of H2, which is hydrogen gas, for the following balanced chemical equation. And so the way this should be written is N2 plus 3 moles of H2 produces 2 moles of NH3, which is ammonium. Okay? So it's asking us to, what are we asked to find? We're asked to find the moles of N2. And so that gives us a direction. Where are we going when we're doing our equation? What do we need to end up with? And then it says that we're going to start with 4 grams, because whatever you're given in the problem, whatever they give you, that's what you start with, and you put it over 1. So we're going from 4 grams of H2, and we have to find moles of N2, right? And so, like I said, we're going to start with what we're given, and we're given 4 grams of H2. So we're going to put 4 grams of H2 over 1, okay? And this is our given. That's what we start with. And then we just put a line there as dimensional analysis. It's just like multiply. So now we need to get to moles. So before we can get to moles of N2, we need to find out what the moles are how many moles are in 4 grams of H2, right? So we know that 1 mole of H2 is equal to 1 gram of H2, right? And so notice how I set this up. We're trying to get from grams to moles. So we're going from grams of H2, what we're given, to moles of our given. And now we can cancel grams of H2, right? And then we're going to go from moles of H2 to moles of N2 using our mole-to-mole ratios from the equation. So we have 3 moles of H2 to 1 mole of N2. And since we're trying to find moles of N2, we're going to put 1 mole of N2 on top and 3 moles of H2 on the bottom. And then all we have to do is multiply through, because now our grams of H2 have canceled, our moles of H2 have canceled, and all we're left with is moles of N2. And so we can go ahead and write that unit out here and just multiply through. So 4 times 1 times 1 is 4, divided by 3, right? 4 divided by 3 equals 1 1/3, or 1.33, repeating, moles of N2. Okay, so let's do another one. This one is moles to moles. Whoops. Here we go. Okay, so this one is moles to moles, and let's set that there. All right, it says using the reaction below, how many moles of CO2 can be produced when 2.25 moles of C3H8 react? And again, this should be C3H8, oops, H8, and CO2 with subscripts. Remember, the subscripts tell us how many atoms. So we have 2 atoms of oxygen, 1 atom of carbon, and so forth. Okay, so it's asking us, again, how many moles of CO2. So we're interested in CO2 and C3H8. What they're giving us is the moles of C3H8, and then we have to find the moles of CO2. So this is going to be a short one. So we have 2.25. This is our given, right? This is our given right here. This is what they're giving us. And so that's what we're going to start with, and we're going to put it over 1. So 2.25 moles of C3H8 over 1. Right? And again, we're starting with our given. And now we need to put moles of C3H8 on the bottom here, right? So we can cancel. And I can't write today. C3H8. And on top, we're going to use the molar ratio, right? How many moles of C3H8? What's the molar ratio to the CO2? So here's our C3H8. We assume 1, so we have 1 mole of C3H8 to 3 moles of CO2. Oh my goodness. 3 moles of CO2. Okay? And I don't know why that, I wrote that in blue, but we can just go back over it in black. Okay. And then now, notice that our moles of C3H8 cancel, and we're at moles of CO2, so this is, we've just used the molar ratio from the equation, or the reaction. And now we can put and we're done. I forgot we were just going to moles. So, because it's asking us how many moles of CO2, right? That's what it's asking. And that's what we have here. And so now all we have to do is multiply 2.25 times 3, which is 6.75 moles of CO2. And you're done. Okay, let's try one more. This one's going to be a little bit different and a little bit longer, I believe. And so let's make sure that this is written out correctly because my subscripts, I typed them in right, but they didn't come out right. So this should be C7H16 plus 11 moles of O2 produces 7 moles of CO2 plus 8 moles of H2O. Okay? It says use the following equation to determine how many grams of O2, and so we're interested in the O2 here, right? How many grams of O2 are required to react with 10.5 grams of C7H16, which is this one right here. So these are the two we're looking at. And we can see that the molar ratio is 1 mole of C7H16 to 11 moles of O2, right? So we just need to remember that just to look at those ratios. And we always assume 1 here since there's no coefficient. And so again, we're going to start with what we're given. And this is our given. This is what they're giving us in the problem. So we're going to start with 10.5 grams of C7H16. And notice that I'm using my units because it's much easier to go back and check that you've set everything up right if you can cancel everything except for the grams of O2. So we're going to put that over 1. That's our given. We always start with what we're given and put it over 1. And again, we're trying to go from grams of C7H16 to grams of O2. So the next thing we're going to have to do, always, we have to find the moles, right, of C7H16. And so we need the molar mass of C7H16. So molar mass. And I need to do that math. So 12 times 7 is 84. So for C7H16, we have 7 times 12, right, for carbon, because carbon is 12, and that's 84. And you're going to add that to 16 hydrogen, and hydrogen is just 1 times 16. So we have 100, right? 100 grams is the molar mass. And so we have 100, or 1 mole, right, of C7H16 is equal to 100 grams of C7H16, okay? And notice we put the grams, we have grams here, so we put it in the denominator so that we can cancel, right? And so now those cancel. And then our next step, we need to go from moles of C7H16 to moles of O2. And here we're going to use our mole to mole ratio, or our molar ratio. And we just get that from up here in the problem, right? So that comes from here. And so we have 11 moles, 11 moles of O2 over 1 mole of C7H16. And I can make this a little bit, hopefully, see if I can draw this line a little bit better here so you know where that's coming from. So there and there. Okay. And so now notice that we can cancel out the moles of C7H16, right? Excuse me. So, but they want the grams of O2. We have moles of O2 now, but they want grams of O2. So what do we use? We use the molar mass of O2. And the molar mass of oxygen, oxygen is 16, and we have 2 of them. So to find that, we just, for oxygen, we take 2 times its molar mass, which is 16, and we get 32. And so we have 32 grams of oxygen over 1 mole. And now we cancel out moles of oxygen, right? And we're left with grams of O2. And this is exactly what we're trying to find up here. And so now all we have to do is multiply through. And so we're taking 10.5 times 11, which is 115.5, and then times 32, which is 3,696, but we need to divide that by 100, right? And so our answer is going to be 369.6 grams of O2. Okay. Well, I hope that helped. If you have any other questions, be sure to let me know.